In the last video, we looked at balancing equations where the formulas were already written. So all you had to do was balance. Here's the next level. The next level, you got to write the formulas, and then we'll balance it. Now, there are a few things we have to be a little bit aware of, and number one is going to be writing our ionic formulas. We have to be a freak about watching all our charges and our polyatomics, so that formula writing, it doesn't go away. It's here forever, or at least until June. We also have to remember our diatomic elements. So when the following elements are in their elemental form, which means that they're not bonded to anything else, they come in pairs. They're diatomics. They kind of follow a little pattern on the periodic table in that you've got hydrogen way up in the corner. And the other ones, I think they kind of make like the number 7. So it'll be nitrogen, oxygen, and all the halogens. Fluorine, chlorine, bromine, iodine, and astatine. So if they're listed as elements, meaning they're not bonded to anything else, then we have to write their formula as diatomic. For example, check out number 1. Nitrogen plus hydrogen form nitrogen trihydride. Here's what we mean by elemental form. Nitrogen, it's not bonded to anything. So I need to write his formula as N2. He's a diatomic element. And so is hydrogen. H2, diatomic. But in a bond, in a compound, now we'll either use charge, if it's ionic, or if the compound is covalent, meaning that it's all nonmetals, then we'll have something like this, nitrogen trihydride, where the prefixes tell us the ratio. Nitrogen trihydride, NH3. Oh, there, you don't need charges, you don't need anything. Just use the prefixes to tell you the ratio in the formula. And now the balancing, this should be the easy part. I'm going to need 2 nitrogen, so I'll put the 2 way out in front. Not only does that double my nitrogen, but it also doubles my hydrogen. 3 times 2. Cool, done. 2 nitrogen, 6 hydrogen. Now in number 2, sodium is not a diatomic element. Most elements are not diatomic. I mean, it's only these couple. Most of them are gases. They're all nonmetals, like all the halogens. Sodium is not. So it's just Na. But oxygen gas is diatomic O2. So here's an example of an ionic product. It's a metal nonmetal. Now I need to write its formula by balancing charge. Sodium is a +1 ion. Oxygen is -2. I'm going to need 2 sodium. Done. The most common wrong answer is this, NaO2. I'll say Na plus O2 makes NaO2. No, that's not the formula of sodium oxide. We have to balance it with charge. And now we can balance the entire equation. It looks like I'm going to need 2 sodium, 2 oxygen. If I want to get 2 oxygen on the product side, I got to go all the way out in front. But all rats, that also doubled my sodium. And that's why they call it balancing. Instead of 2, I really need 4. Now we should be set. 4 sodium and 2 oxygen on both sides. Nice. Something like 3. Propane. It's one of those organic carbon compounds. Here's kind of why we did a little organic chemistry back in the day. Propane. Prop is the prefix for 3 carbons. Ane means single bonded. And then we give carbon an octet by adding hydrogen. The best way to get the formula of propane is really just to draw it. And then we'll add up the carbons and hydrogens to get the formula. C3H8. Oxygen is diatomic as an element, not bonded to anything. And then I have carbon dioxide and water. There, not bad. Okay, so we got the formulas, we balance. 3 carbon. All right, 3 carbon. 8 hydrogen. 4 times 2 is 8. And now I got to check my oxygen. Here's 3 times 2 for 6. 6 and 4 is 10. 5 times 2 is 10. The total number balance on both sides. Nice. The last one listed here has lots of formulas. Lots of ionic formulas. So you got to be a little careful with your charges. Silver 1 means silver is +1. Nitrate is the polyatomic -1. Oh, I like that. Silver, nitrate. It's balanced. Magnesium chloride. Magnesium is in group 2. It's +2. Chlorine -1. To make this neutral, we will need 2 chlorine, Cl2. Sometimes when I have these equations with lots of ionic formulas, I like to write the charges on paper because often the charges will stay the same on both sides of your equation. So if you look it up once, you can use it twice. Now here they kind of hint that silver is also +1. Silver 1, chlorine -1. Oh, cool. Neutral. AgCl. I already looked up the charge of magnesium, +2, nitrate -1. So again, if you would look this up on your polyatomic chart, you look it up once, you can use it twice. I'm going to need 2 nitrates, and since it's a group, it must go in parentheses. Cool. And now I just balance it. Nitrate stays the same on both sides. It looks like I'm going to need 2 of them. Originally my silver was balanced, but I'm going to need 2 nitrates. So by putting the 2 out in front, I'll also double my silver. 2. Magnesium, magnesium, 2 chlorine. What do you know? 2 chlorine. It's balanced. You just have to be a little careful with your formulas. If it takes you more than 60 seconds to balance one of these equations, I would put money down. You have a formula that's written wrong. That usually fixes it. One little subscript or forgetting your parentheses and the whole darn thing doesn't balance. So check those formulas really closely. So again, at this point, I would suggest pause the video, try some of the last few, bring it back, and see if you're getting those formulas and balanced equations correct. All right, here's the answers to the last half. Again, in 5 and 7, lots of ionic formulas. You have to be a freak about those charges. Write them on paper if it helps. If aluminum is +3 on the reactant side, it's +3 on the product side. Look it up once, use it twice. If those formulas in 5 and 7 are written correctly, the balancing is easy. Number 6, ethane. You may need to draw ethane. Eth is the prefix for 2 carbons, single bonded. And then I would add the hydrogens to give all carbons a full octet. And that's the best way of getting the formula. C2H6. Then you just have to be kind of careful with your oxygens, that you have the total amount of oxygen the same on both sides. And finally, ones like 8 and 9, be careful with those polyatomics, or in this case, diatomics. I guess polyatomics more so in 5 and 7, the sulfate and hydroxide. Be careful that you have the parentheses correct and the formula is correct. 8 and 9, when fluorine and chlorine and oxygen in 9, when they are not bonded to anything, they need to be written diatomically. But when in a compound, then we balance with charge. So for example, like in 8, sodium chloride is just NaCl. It's not NaCl2. Chlorine is only Cl2 diatomic when it's all by itself as an element. But in a compound, I'd balance them with charge. So take as much time as you need. You can pause this, check your answers to 5 through 9. If you're getting the formulas right, they will balance. I promise they will balance. But if you're not getting them to balance, it's probably a formula. 90% of the time, it's a formula that's written incorrectly. If those formulas are just not happening for you, then it might be time to come in and get a little formula writing intervention.